So as we heard from Terje, why we're here exactly today, we want to talk about naturlig klimatisering, which is slightly different to, or is quite different to natural ventilation. But it's essentially a utilization of natural resources to address needs for cooling, heating, daylight, ventilation, and sun shading, which is basically maxing out free resources before we supplement with technology, which sounds pretty smart, right? This is something I stole from one of Niels' presentations, but it basically describes the similar trend to, as Terje explained now, the yellow line obviously being investment in HVAC, VVS technology, and as you can possibly imagine, this isn't entirely sustainable. So I'm going to hop just a little bit. This is an experience or a erfaring seminar, so I want to tell you a little bit, just very, very briefly about my background. I'm obviously at least 50% British, which means I was born cold. Anybody who's been in a British house for any period of long length of time knows exactly what I'm talking about. So I was actually very intrigued as to how natural climatization was actually possible. Now, the UK, being a nation of geniuses, has developed an entire industry looking at precisely this, let's say task-based solutions, if we can call it that at best. And these obviously are clearly twinned thermal comfort slippers and possibly a form of birth control. Daylight management in form of beautiful net curtains, obviously offering some glare control, some privacy, and some more thermal comfort, perhaps increasing relative humidity. And then finally, some thermal comfort and possibly acoustics. I'm really never really worked that one out. Flawed, of course, but nonetheless inherently human. And seriously, we have to do better than that. But let's start with the buildings. And I'll hop straight into, this is House Zero, which is a collaboration project together with Skanska Teknik and Windowmaster and Harvard Center for Green Buildings and Cities. Their own headquarters, so they'll be living in what they create or in what we create. And a project completely focused on doing absolute maximum with absolute minimum. So everything has at least, or every design grep that we take has at least two functions. Specifically, this is employing, as you can see on the left here, this is Windowmaster system actuated windows. We've taken out, this is a rehabilitation project of 1920s timber house, so we've taken out some areas which obviously increase volume, left the infrastructure in for the sake of stability, but it adds a lot of daylight, it adds volume, it adds quality to the acoustics through the height, and obviously daylight coming in from all kinds of sides. This doesn't take a rendering to tell us that this could be quite a nice space to work. Also employing the 000 that Terje mentioned, this, let's say, criteria of zero bought energy for heating, cooling, zero mechanical ventilation, zero emissions as well, actually, in this project, plus 100, or at least an attempt to reach 100% daylight autonomy, which is quite difficult. But we're around 93% for most of the spaces. Additionally, when we're talking about task-based solutions, we laugh a bit at the slippers and stuff like that, and thank God you did laugh, because I was a bit worried if you wouldn't. The desks, for example, is one particular example of this, is actually offering haptic surface or alternative surface based on the temperature. This is basically what we feel, which is essentially what we're talking about today, is how we feel. So on one side you have a wooden surface, which obviously different kind of thermal conductivity means that it might be a warmer to the touch. On the other side, a composite material that's obviously cooler to the touch. It's basically addressing the basic human needs as well as reflecting daylight. So what we feel, the psychology of environments as a design driver is extremely exciting. It's had a lot of value to our practice. But luckily, when it comes to psychology of environments, we don't have to start from scratch. This is Paul Ole Fanger, who started, a very smart guy, who basically did an experiment, but he tested subjective response to stimuli, heating, cooling, temperature, which basically forms the basis of modern VVS and HVAC theory. This is ASHRAE psychometric chart. However, what we might not be particularly enlightened about is that the same criteria that are developed here can be better, or if not equally, matched through mechanical ventilation, balanced ventilation, but at the same time as natural ventilation or any other thing that we care to come up with. So it's simply a matter of interpretation. On the one hand, we have a version which says push, pull, heat, cool, reclaim, recycle. It's basically more ducting, more larger aggregates, more sonic damping, because this obviously makes more noise. And I guess when it comes down to it, it's hardly surprising that the graph that we saw earlier and the trends are moving upwards. And so entrenched, perhaps, there's not so many VVS people here, so I can say that. So entrenched is that we're simply using arrows to explain air movement. And as we probably are all aware, that this is not how air moves unless you push it very much and pull it very much. Basically an internal combustion engine. So this is basically what Arnkel refers to as ønskepiler. And it's perhaps small wonder when the interface that sort of tells us about air movement or describes air movement is looking like this. Sorry. So we all know that also not all environments can be naturally ventilated, of course. Pollution and noise, other factors make it kind of difficult, almost impossible, or in fact impossible, to do away completely with the aggregate. But what we're looking at is simply an alternative that in most cases is well worthy of investigation. Basically means a knowledge shift, a shift from a pre-accepted solution to a better understanding of our external climate. So it means designing climate-responsive architecture, literally bringing the outside in. And when we talk about this, this means for our practice at least, or in particular, is new skill sets, new simulations, a new understanding of external environments that we're putting our buildings in, and how then we respond to that, and how then that the external environment responds to our building. Again, ønskepiler perhaps, but basically designing buildings that respond to climate through understanding the climate first. Again, how we deal with daylight due to availability is simply a matter of studying the site with more precision than perhaps what we've done before, and simply adding more parameters. So what we looked at is basically the Excel sheet that we saw a second ago is now manifest in legible physical models that actually do describe situations that we're experiencing. This is a version of what's now called a klimatisering, which is going to enable us to fill meeting rooms or ventilate meeting rooms with quality, not draft, and that can basically adapt to the loads that we're talking about. And a collaboration, of course, with Window Master, with Yannick, And what he can do with the CFD basically is telling us this is informing the design. And as such, we're able to adapt and it's in an iterative process. This tells us, basically this doesn't make much sense probably, but this is basically a graphical representation of the Excel sheet that we looked at. This tells us that if it's minus 15 outside and plus 20 inside, that at certain distance from the klimakano, and if we make a hole in it that's 20 centimeters or 20 millimeters wide, the temperature will be minus 2 or minus 4.2, 10 centimeters away from the kano. This is kind of, why do I know this? I'm not sure. But basically what it tells us is that we can, it basically informs us what kind of materials we need to make this out of, how we need to insulate, and what kind of situations are happening within the kano. Can we expect icicles to form? Can we expect condensation to form? But we now know that this is not the case. So perhaps the grasshopper is truly mightier than the speed over there. We like to think so. Basically what this means is a lot of positives. Obviously, thanks for the questions, Terry. Everybody is kind of on the side, so basically this makes a lot of sense to us all. This is intuitive. It's basically costs transferred from tech to knowledge. It means a shift in how we approach the projects. There's naturally, we've seen this before in terms of sustainable projects, that it requires a lot more projecting in the first part of the project, but it gives us a predictability. It gives us we're able to see the project in a longer term and understand where the investments lie and where the investments don't lie. So basically, in closing, I think what we're looking at is a new dawn for internal environments. Call them internal ecosystems, perhaps based on the idea that a person is a natural resource, not simply a source of pollution or a warm, varmfuktig plume, has been referred to recently, to be dispatched with this push-pull idea. And quite clearly, we can do better. Finally, I just want to say that personally, from my opinion, seeing as we're on erfaring, and I did launch with the slippers and stuff, that this has offered an incredible amount of value to our practice. It seems to be something that's, at least the process of the research center or the research project seems to have completed together with our understandings from ZEB and materials, embodied emissions and things like this, that somehow we feel perhaps that there's a complete tool set here that's ready for the next iteration. Thank you very much.